This screencast is going to cover the questions posed in the simple harmonic motion 4th hour. So having the questions in front of you is going to help, so make sure you have those. First one we're going to work on is the vertical spring problem. So I have a vertical spring, and the vertical spring has a mass at the end of it, and that mass is 200 grams, but I'm going to convert that to 2 kilograms. And it drops a distance of 0.223 centimeters. Oh, meters, I've already converted that one. So again, make sure with all of these that because so many of them are tied to newtons, that you convert everything into kilograms and into meters. So first thing we have to do is figure out the spring constant, and then we have to figure out the speed of when it's at 10 meters, or 10 centimeters. When we're working on this, what we're going to look at first is that the gravitational potential energy, mgy, is going to be changed into spring potential energy, 1/2 ky squared. Again, you get points on the AP exam if you solve for things algebraically, so do that first. Multiply both sides by 2, divide by y, and I get k is equal to 2 times m times g, all divided by y. So 2 times our mass, 0.2 times g. I'm going to use 9.8 because that's what you would do in your homework. But understand on the AP exam, you can also just use 10 for rapid calculations divided by 0.223. And I solve for this. I get 17.56 newtons per meter. So that's our spring constant K, and that's going to help us in the next part when we want to find velocity. So as it's falling, what's happening is 3 different types of energy are being used. We have gravitational potential, and gravitational potential depends on position, so mgy or mgh. We have spring potential, and that's equal to 1/2 the spring constant times its position squared. And we also have kinetic. And we have to be careful because I've got a K here and I've got a K here, and they're not the same K. So you just want to make sure that you're keeping everything straight. And that's 1/2 mv squared. So what's happening is I'm taking my gravitational potential energy and putting some of the energy into spring potential and some of the energy into kinetic. All the energy, though, together, this is E tote. That the total energy, when I add up all the pieces, has to equal that. So when I am working on this, I am going to say that because of conservation of energy, that the original position I'm going to use, let's use black. The original potential energy for position mgy is equal to the kinetic 1/2 mv squared plus any spring potential 1/2 ky squared. And again, x or y doesn't matter, just make sure you're being consistent in your usage. And I'm going to solve for this algebraically. I want to solve for v, so again, you get points on the AP exam for doing things algebraically, not for solving it. So putting the numbers in now is really not a good idea. As I'm going to solve through is I can write mgy is equal to 1/2 mv squared plus ky squared. and multiplies by both sides by 2, 2mgy is equal to mv squared plus ky squared. Subtract ky squared from both sides, 2mgy is equal to mv squared. And divide both sides by m, take the square root, and I'm left with v is equal to square root of 2gy minus ky squared over m. And when I plug in, I get v is equal to, and again, I'm using 9.8 because that's what you'd use in your homework, but you could use 10. 2 times 9.8 times 0.1, the distance that it fell, minus 17.56 times 0.1 squared, all divided by 0.2. And again, be careful with your parentheses here. And I get my velocity of 1.04 meters per second. This is a really good problem because it's really challenging your ideas of conservation of energy.